Hi friends, for any mechanical competitive exams, basically the questions will come from RS KURMI, from RK chain and IS direct questions and gate 1 mark question. These 4 parts if you cover, your lives will be going to change, because most of the mechanical questions will come from mostly from these 2 parts, and they want to make little bit the paper is difficult, then they will add some question from 3 and 4 part, that is the IS direct questions and some gate questions. So in my channel, what I am going to do, I am uploading all the videos related to RS KURMI, all the objective questions of all subject, as well as RKJ, as well as IS questions and gate questions. So what you have to do, you have to see all the videos and you have to read once in the book, and before exam 10 days before exam, what you have to do, you see these all the videos. So what you gonna do, actually before I will mark the answer, already you studied, already you watched it, this time it will be revision. You will tell yourself that is the answer before I will mark, because it will take some time for when I am reading the question only you will able to identify the answer. So this is the trick to cover all the portions, and we're going to start now. RS KURMI, first topic, that is engineering mechanics. Okay, so engineering mechanics, so you can see here engineering mechanics questions. So we will see all the questions of the particular subject. Like that, we will finish all the chapters. You can see the content of this book questions. See here, engineering mechanics, strength of materials, hydraulic fluid mechanics. Like this, all the chapters I will finish. Now today we are going to do the video on engineering mechanics. This contain total 325 questions. So we will divide this subject into 2 videos. In the first video, in this video, we will cover first 150 questions. In the next video, the remaining 175 questions will finish. So with these 2 videos, this subject will be gonna to finish of the RS KURMI all the questions. Okay. Now we'll see the first question from here. Okay, from here. Okay. Now RS KURMI. So the term force may be defined as an agent which produces or tend to produce or destroy or tend to destroy the motion. So this will be agree, means force can be defined as it can produce or destroy or tend to destroy the motion. So these all things will be possible by force, that's why it is agree. Force while acting on a body change its motion. Yes, balance the force already acting on it, give rise to internal resisting force, all of this above. So this is the correct answer. In order to determine the effect of the force acting on a body, we must know, what we have to know, if any body force is acting, what we have to know, magnitude of force, how much kg of force, line of action of force, nature of force, that is whether the force is pull or push. So all of this should be needed. Next, the unit of force in SI units is, you already know, that is Newton. Correct. 1 kg force is equal to 9.81 Newton. Correct. The resultant force is a single force which produces the same effect as produced by all the given forces acting on a body. Yes, correct. So this is the body, on this the number of forces is acting, but resultant force is what? That is the opposite to these all the forces, and this is the single force equal to all these 3 forces. So that's why it's correct. Okay. Next, The process of finding out the resultant force is called dash of a forces. It is called as a composition of force. Okay. The algebraic sum of the resolved parts of a forces, number of forces in a given direction equal to the resolved part of their resultant in the same direction. This is known as a principle of resolution of forces. So what the resolved, you can keyword here resolved part. So you can the algebraic sum resolved part. So principle of resolution of forces, this definition. Okay, like that you can remember. Vector method for the resultant force is also called as a polygon law of forces. Yes, correct. The resultant of two forces P and Q acting at an angle theta is called. What is the formula for P square plus Q square plus 2PQ? Yes, correct. You are saying 2PQ cos theta. This is the cos theta. Remember, cos theta will be there at the end and all are pluses. Okay, next. 11th question. 11th question. If the resultant of two forces P and Q acting at an angle theta makes the angle alpha with the P, then tan alpha is equal to Q sin theta by P plus Q cos theta. So this is our answer. The resultant of a forces P and Q acting along the same direction, same straight line, but in the opposite direction, given by P minus Q. So that's already you know. Whenever opposite direction P minus Q, when the same direction forces are acting, then those two forces will be added. 1 and 2 you should be add. If it is opposite direction, you have to subtract. Okay. Next, what is this? If you see the next question, the resultant of a two equal forces P acting at an angle theta is given by the. So 13th question answer is what? B. 2P cos theta by 2. The resultant of two equal forces P making an angle theta is given by. So what is this one? Under root of both are same. P square, one more wholes also P square will be there. 2P into P square cos theta. So in all this what common is there? P square is common is there. 1 plus 1 plus 1 plus 2 cos theta. So like this P will come outside. 2 plus 2 cos theta under root. So P into, if you take 2 plus 2, 2 is there, okay, 2 is there here, so you can 2 common out, take 1 plus cos theta under root. Okay, P into under root 2 into 1 plus cos theta means, formula is what? Cos square theta by 2. 2 into cos square theta by 2. So this 2 into 2, this is 4. 4 means 1 2 will come outside, and cos square theta by 2, so cos theta by 2. So that's why this answer is 2P cos theta by 2. So 13th is B. Got it. The resultant of two forces each equal to P acting at a right angle. Now in place of theta, in this question only, just in this answer only, you substitute theta is equal to 90. 90 by 2 means 45. So 2P into cos 45 is 1 by root 2. So root 2, 1 root 2, 1 root 2 will give. So what you get? Root 2 P. Root 2 P. So root 2 P, whatever left, that one is our answer. Okay. Next question. The angle between the two forces when the resultant is maximum and minimum respectively are, what are that? That is the 0 and 180. Remember the values. If the resultant of two equal forces has the same magnitude as the either of the forces, then the angle between these two forces is how much? That is 120 degrees. That is 120 degrees. The resultant of two forces P and Q is R. Q is double, then the new resultant is perpendicular to P, then Q is equal to R. Okay, you have to remember like this only, because this question directly they will copy for the exam. Two forces are acting at an angle 120 degrees. The bigger force is this much. The resultant is perpendicular to smaller one. The smaller force is how much they are asking. So this one will be 20 Newton. I can solve this question, but it will be take more time, little bit more time. It is so you can, I think, do it. If you need the solutions of this question, just comment in the comment box. You can comment. I will do this all the solution, and I will provide you an PDF. Okay. The term leverage and mechanical advantage of a compound lever got the same meaning. Yes, it's got the same meaning. Okay. Number of forces acting at a point will be in equilibrium if all the forces are equally inclined. Sum of all the forces are 0, so it should be both. So equilibrium means sum of the vertical forces should be 0, sum of the horizontal force should be 0, and sum of the movements also should be 0. These three conditions should be satisfied, but out of these three, 2 is given. Okay, so these two conditions has to satisfy. Next, if the number of forces acting at a point, their resultant is given by the, so under root of horizontal force square plus under root of vertical force square. So this is the B is the answer. So what is the two equal forces at right angle acting at a point, the resultant are acting along their bisector and in opposite direction is, so that's already we know 2p into cos theta by 2 is the, when two forces are acting, that resultant is equal to, so if you substitute in this one 90 degrees, then it is root 2 p, it is root 2 p cos, because here cos 90 by 2 means cos 45, 2p into cos 45 means 1 by root 2. You can, this 2 you can write root 2 into root 2, 1 root 2 will cancel, so root 2 into p is left, that is the answer. If the number of forces are acting at a point, the resultant will be inclined at angle theta with the horizontal such that tan theta is equal to, this is by here, tan theta is equal to under summation of vertical forces by summation of horizontal forces. So remember the formulas, these are okay. Next 24. So in this whole polygon law of this type of question, the triangle law state that two forces are simultaneously. So triangle, how many sides will be there? 3 sides. Then 2 sides will be there. Third side should be in the opposite direction. Be represented in magnitude direction when two sides of a triangle taken in order. Their resultant may be represented in magnitude and direction by the third side. So resultant is represented by third side of a triangle taken in opposite direction. So these two are in this direction means this should be in the opposite direction to these two sides. Okay, so this is true. Polygon law of forces state that if the number of forces acting simultaneously on a particle be represented in magnitude and direction by a sides of polygon taken in order, they resultant in the magnitude and direction by a closing side. So polygon means a number of so many number of sides. So this closing side should be in the opposite direction to that all the remaining sides. Okay, polygon taken in the opposite direction. So this is the correct. Okay, next. Concurrent forces are those. So first of all, concurrent and coplanar. Coplanar means in the same plane forces will be there, only x plane or y plane. Okay, next coplanar. Now concurrent, this is coplanar and a planar. You can use the word planar. Concurrent means all the forces will meet at the same point. So they may not be in the same plane, but they will meet at one point. So one force is coming from x axis, one plane is coming from y axis, one plane is coming from z axis, z plane, but all are meeting at one point. So this is concurrent. Concurrent means meeting at one point. Coplanar means all the forces may not be meet, but they will be at on the same plane. So now here you can easily you can answer. Concurrent forces are those forces whose line of action meet at one point. I told you just now, meet at one point. Okay, next. If the resultant of number of forces acting in a body is 0, the body will not be in equilibrium. It should be in equilibrium. It should be in equilibrium. But what is said here? Not he said. So it is no. Actually, it should be in equilibrium. If the forces which meet at one point, they are meeting at one point, their line of action also lie on the same plane. But these three also in the same plane. So 3 also in the same plane and they are meeting at one point. First of all, they are meeting at one point means concurrent. They are in the same planes means coplanar. So they are concurrent and coplanar. So they are coplanar and concurrent forces. 28 is E. Like that you can do it. The forces which do not meet one point but their line of action lie on the same plane are known as a coplanar non-concurrent forces. Is correct. Correct. The forces which meet at one point but their line of action dash on the same plane are called as a non-coplanar concurrent forces. So they do not lie. Non-coplanar means they do not lie on the same plane. The forces which do not meet at one point and their line of action do not lie on the same plane are known as a non-coplanar non-concurrent forces. Because do not meet, do not lie. So both opposite. Non-coplanar, non-concurrent. In the all the three options, nothing is there. So none of the above. Answer is non-coplanar and non-coplanar and non-concurrent. That should be the answer. Coplanar non-concurrent forces are those forces which coplanar non-concurrent. Coplanar means they meet at one point, but not in the same plane. Non-concurrent means they do not meet at one point. Coplanar forces whose forces which coplanar is said coplanar means in the same plane. So coplanar concurrent also is said meet at one point and their line of action also lie in the same plane. Non-coplanar concurrent forces. Non-coplanar means they, first of all, concurrent means they meet at one point. Non-coplanar means they not be in the same plane. So meet at one point, their line of action do not lie in the same plane because non-planar is said. Non-coplanar non-concurrent means do not meet at one point and their line of action also do not lie in the same plane. If the three coplanar forces acting on a point in a equilibrium, their each force is proportional to sine of angle of the angle between these two. This is called as the this law. This law is called as a Lami's theorem. We call as a Lami's theorem. What is this? If it is this one is one force, this is one more force, this is one more force, this is P, this is Q, this is R. Then what is writing P by whatever the opposite angle is there. This is suppose 100. This is suppose one more 100 and this is suppose 200 means 160 should be there. This one total 360 for circle. So P by P opposite 100 degrees is there, sine 100. Q by Q opposite 160 is there, Q 160 sine 160 and R by sine R opposite to 160 is there, Q by 100. So like that we have to write. So three coplanar forces point in a equilibrium. The each force is proportional to sine of angle between the other two. So as correct. Okay, it's correct. Next question. This one only. Whatever the just now I explained that is there. P by sine alpha, the opposite. Q by sine beta. R by sine gamma. So P by sine alpha varies beta gamma. So this is our answer. According to Lami's theorem, if the three forces acting at a point in equilibrium, each force is proportional to sine of angle between the other two. Lami's theorem important. Okay. If a given force acting on a body dash the position of the body but keeps in equilibrium, then the effect is to produce the internal stress in the body. Okay. So if the force acting on a body do not change, so you can see body is not changing. If someone is hitting to you but you did not move from here to here, but what will happen wherever someone is hit to you, there the molecules will be transformation will be there. It will go inside, some muscles will go inside. Means what is happening there, the internal stress was creating in your body but you are not moved in the position. So do not change, but their effect is produces the internal stress in your body. Next, if the three forces acting at a point are represented in magnitude and direction by a three sides of a triangle taken in order, the forces are in equilibrium. Yes. The number of forces acting at a point represented in magnitude and direction by the three sides of a triangle taken in order, the forces are not in equilibrium. No, just now we said it should be in equilibrium. Okay. The moment of a force. The moment of a force. Now see, moment of a force means what? So this is the force, some force is acting. It makes some turning effect with a fixed point. It is a turning effect produced by the force on the body on which it is acts. Yes, correct. It is making some this rod to rotate like this. Some point of time this one, some point of time here, some point of time here. it is equal to the product of force acting on the body and perpendicular distance. So this momentum, how we will calculate? Suppose this is 2 meter, so F into 2 meters. F may be some 5 newtons, then 5 into 10, that is the 10 Newton upon meter is our answer, the turning moment. So correct this one. The force acting on a body and the perpendicular distance point of the line of force. It is equal to twice the area of the triangle whose line are represented by the whose vertex is the point moment is taken. So all of these are correct. The moment is said. Moment just now what I told with respect to what he said. Whoa. So this distance into this P. So P into OC. So P into OC where is there? That is our answer. Okay. I hope you are getting all. Okay. If the number of coplanar is said. Coplanar means all the forces in the same plane. Forces acting at a point B in equilibrium. The sum of the clockwise movement must be equal to the sum of the anti-clockwise movement because it should be in equilibrium is said. Equilibrium means the same should be there and the resultant should be 0. The resultant should be 0. Next, this theorem, this question very important. So many exams has. Waringan's theorem of a moment state that if the number of coplanar forces acting on a particle are in equilibrium, then the algebraic sum of their moment about any point is equal to the moment of their resultant force about the same point. So this is the statement of that one. According to law of movement, if the number of coplanar forces acting on a particle are in equilibrium, then according to law of moments, this is law of moments, this is Waringan's theorem of moments. The algebraic sum of their moments about any point in their plane is 0. Here, any point in their plane is 0. The algebraic sum of their moment about any point is equal to moment of their resultant force about the same point. That is the Waringan's theorem. You have to remember like this. For any system of coplanar forces, condition for equilibrium is that coplanar forces, for any case, algebraic sum of horizontal, I told you for equilibrium what are the condition? Horizontal forces should be equal to 0, vertical forces should be equal to 0 and all the movement should be equal to 0. Then only that body in the equilibrium. See, algebraic sum this should be 0, vertical component should be 0, movement should be 0. The forces whose line of action parallel to each other and they act in the same direction are known as, so parallel to each other and they are in the parallel to each other in the same direction are known as like parallel force. Like means same direction, parallel means they are parallel. Three forces, these all having the line of parallel to each other but in the opposite direction, these forces are known as a unlike parallel forces because they are parallel but unlike because one force is in the opposite direction, like this. Maybe some force is in the opposite direction. 49D. Okay. Two like parallel forces acting at a distance of 24 meter apart. So this is the one force and this is one more force. How much distance is there between these two? 24 mm. So what is saying? The resultant is 20 Newton if the line of action of the resultant is 6 meter from any of the force. So this is the some force 1, this is some force 2 and there is a some resultant force that is at some middle distance. It should be in the opposite. And how much distance from any one of the force? I am taking bottom 6 mm from any given force. The two forces are they are asking. So sum of the horizontal forces we have to calculate. What is the sum of the horizontal forces? This is the 24, this is 20 Newton. So F1 plus F2 is equal to 20 Newton. Then moment about this point, this is 6 means total 24 means this should be how much? This is 18 mm. So F1 into moment about this resultant force is 0. So F1 into 18 is equal to F2 into 6. So F1, this 6 you take this side. So 6 ones are 6 threes are. So 3 F1 is equal to F2. 3 F1 is equal to F2. Now you substitute in this equation, in place of F2 you substitute 3 F1. So F1 plus 3 F1 is equal to 20. So 4 F1 is equal to 20 F1 is equal to 5. If F1 is equal to 5 and sum is 20, then F2 is how much? 15. You have to substitute F1 in the first equation. So you get, so 5 and 15 are 15 and 5. So this is our answer. Okay. 50 question is A. If a body is acting upon by the number of coplanar non-concurrent forces, it may be number of coplanar, they are in the same plane, but they are non-concurrent. They are may not be meet at same point. This is the body. Okay, then rotate about itself without moving may be possible. Move in the one direction, rotating about itself may be possible. Be completely at rest, yes, possible. All of these, yes, all of these are the correct. Next, a smooth cylinder lying on a convex surface remains in dash equilibrium. See, this convex surface means like this hill. You keep this cylinder on this here. What will do? It will fall down. So what will be that? Fall down means it is unstable. This is unstable. If it is convex instead, it is convex means this one. If you keep here cylinder here, always it will be in this area only there. It won't fall away from this hill or this spoon like shape. Then that is stable. Okay, stable. When you ball, you keep here. When you ball, keep here. When you plane on this one, this is unstable. This is stable. This is neutral. In neutral, when you hit this ball, it will go some distance in the same direction. It will be stop in that same direction on same plane. In stable, always after some movements, it will comes to its initial position. But in neutral, it won't come in its neutral position. It will change its position. But in unstable, it won't come to its initial position. So that's thing you have to remember. Three forces acting on a rigid body. Three forces acting on a rigid body are represented in magnitude and direction and line of action of a three sides of taken in order. The forces are equivalent to the couples whose magnitude is equal to the area of the triangle twice the area of the triangle. So this should be moment is always twice the area of the triangle. So that's one you have to remember. Okay. Next, the principle of transmissibility of forces states that when the force acting on a body, its effect is same at every point. It's a line of action. So this answer, actual answer is this one. They given this answer in the textbook, but that is the wrong answer. 54 C they given, but this is the correct answer. Principle of transmissibility of forces stated when the force acting on a body, its effect same at every point on its line of action. So this answer is given in the R.K. Jain. A smooth cylinder lying on a dash is called as a neutral equilibrium. What we called neutral equilibrium means what I showed. This is the horizontal plane. Horizontal means it is not like this, it is not like this. If it is like this, concave, then stable. If it is convex, then unstable. The three forces acting at a point be represented in magnitude direction by three sides of triangle taken in order whose the forces shall be in equilibrium as correct. 57. Two equal and opposite parallel forces whose line of action are different can be represented by a single force parallel to the given force. Can we do? Yes, we can't do. Two equal and parallel forces whose line of action are different. So this one is 1 and this one is 1. And they are equal. So 5 and 5 can be represented by a single parallel force is given by the. So you can't draw one more parallel force opposite to those and you can't balance this because it will be make to rotation. When two parallel is there, same direction, then you can balance. But one is parallel, one opposite direction, two forces are there, then you can't balance those forces with a single force. Okay. Next, two equal and opposite parallel forces whose line of action are different form a couple. Best. This is one force. This is one more force. Distance sum is there. These two together will make a couple. These together make a couple. These two will rotate this object. Couple producer. Now couple what is making here? It is rotating. So rotational motion. Just now we said. Which of the following statement is correct? So this is all of these are correct. Algebraic sum of forces are constituting a couple is 0 because one is this one and one is this one. 5 and 5 both should be, one is in this direction means positive, this direction means negative, both sum should be 0. 0 is happened. The algebraic sum of the force constituted in the couple about any point is same. The couple cannot be balanced by a single force, but it can be balanced only by a couple of opposite signs. This is plus and this is minus and should be same. Now you see the resultant of two forces P and Q acting along a same straight line but in the opposite direction. So P minus Q. So P is greater. That's why P I am writing here. The resultant of two like parallel forces P and Q, what will be there? Two like means same direction, P plus Q. The resultant of two equal forces P making an angular. Two equal forces, what is there? We know 2P cos theta by 2. The angle of inclination of the resultant of two forces P and Q with the force P is given by the Q sin theta by P plus Q cos theta. This is the angle of inclination of a resultant of two forces. Okay. The force induced in a string. The force induced in a string AB due to the load W as shown in the figure is, so this one how you can calculate? By this theorem you can calculate. Which theorem? Lam's theorem you can calculate. So otherwise you can calculate by the this normal method also. This is the force, string is, then this one is the force. So this will be F cos theta. F is in the string, F sin theta. So F cos theta is equal to W, F sin theta is equal to W. Okay, F sin theta is equal to W. So F is equal to W by sin theta. W by sin theta. W by sin theta. So 1 by sin theta is what? Cosec theta. So F is equal to what? W cosec theta. So 62 is what? D. W cosec theta. Because basically we have to call it this force. The force induced in the string BC to the load W as shown in the figure. So F already we know, that is W by sin theta or W cosec theta. You substitute in this place. So because they are asking the BC was the force. So W sin theta or W cosec theta into cos theta. Cos theta by sin theta, cot theta. W cot theta. W cot theta. Okay, like this we have to do. The point through which the whole weight of the body acts irrespective of its position is known as a center of gravity. The term centroid is the same as center of gravity. Centroid is same as center of gravity. Irregular body may have more than one center of gravity. 66 yes. So this is some irregular body. So here this much of force is having some center of gravity, and this much of force having some center of gravity. So CG1, CG2. The center of gravity of a rectangle lies at the point where the two diagonals meet each other. Yes. So this is the rectangle. So wherever they are meeting, there its center of gravity is there. Center of gravity is a triangle whose medians intersect each other. So this is the triangle. It's a median wherever meeting. So this is called as a median. This is called as a median. So wherever they are meeting, there will be their center of gravity is there. So this point is their center of gravity. Next 2. The center of gravity of an isosceles triangle with a base P and side Q from its base is, so this formula you have to remember, they will directly copy. So under root of 4p square minus q square by 6. So under root will be there for in the option. In all remaining options is not there. So why I am saying, they will just copy the question. They won't prepare. The center of gravity of a equivalent triangle with each side A is dashed from any of the sides. So 70 is what? C A by 2 root 3. Remember the answers only. The center of gravity of a semicircle lies at, so this is the semicircle, this is the center of gravity. From base at what distance it is lies? That is 4r by 3 pi. 4r by 3 pi. The center of gravity of a hemisphere lies at a distance of 3r by 8 from its base. Now hemisphere means this. Okay, this is the base. So this is some center of gravity. So what is the distance? This is 3r by 8. Correct. Next, the center of gravity of a trapezium with a parallel sides A and B lies at a distance of y from the base B as shown in the value of y is. So this y, how much they are asking. So this y is how much they are asking. So that is h by 3 into 2a plus b by a plus b. So that is 73 is C. So h by 3, this will be 3 and numerator will be 2a plus b by a plus b. So this a plus b will be common. So this 2, 3 you have to remember. 2, 3. So 2 will come first, after that 3 will come. So down 3. Like that some way you can remember. Okay. So answer is this one. The center of gravity of a right circular solid cone is a distance of dash from. So this is the right circular solid cone. How much distance from this base it's saying? That is h by 4. How much? H by 4. H by 4. Next one. The center of gravity of a right angle triangle is lies its geometric center? No. So this is the right angle triangle. It's geometric center where it is. Suppose geometric center is here, but it won't be like here. It will not be at exactly geometric center. For circle it is geometric center. For equilateral triangle it is geometric circle. Means when you cut that body, some plane it should be in some plane it should be symmetrical. Then only it what will be there? Its center of gravity is at its geometric center will be there. Now you can tell this answer. Center of gravity of a rectangle is where it is there? Intersection of its diagonals. Center of gravity of triangle, intersection of its medians. Center of gravity of circle at its center. Center of gravity of semicircle 4r by 3 pi. Semicircle means 4r by 3 pi. Hemisphere means 3r by 8. Right circular cone h by 4. Like this you can remember. Okay. The center of gravity of a quadrant. The center of gravity of a quadrant of a circle lies along its center of radius or at a distance of. So or from a distance of where it is asking. So where it will be 77b 0.6. So this is the quarter circle. So where its center of gravity is lies, it's asking. So that distance is 0.6 or 0.6 or there is a T section. These are the dimension. Its center of gravity from its bottom is, so just you remember this answer 87.5. Directly they will give you. Okay. A circular hole of 50 mm diameter is cut from a circular disc of this much diameter. The center of gravity of this section will lie. Now this one is open. Now center of gravity is somewhere here or somewhere, the major portion. So is in the shaded area. Shaded area means there is a body is there physically. Okay. Next. Moment of inertia is the second moment of area, second moment of mass, second moment of force, all of this. Okay, this is all of this. 81. Unit of moment of inertia of area. Whenever area they will tell you direct by 4. mm power 4 or meter power 4. But whenever moment of inertia of area they will tell. Unit of mass moment of inertia whenever they will tell you. Mass means kg, area means meter square. So kg-meter square. Now, a spherical body is symmetrical about it is in the perpendicular axis. According to Routh's rule, the moment of inertia of body about its axis passing through the center of gravity. Center of gravity is C ms by phi. S means sum of the squares of the two ms circles. So Routh's, according to Routh's, spherical body symmetrical about its perpendicular axis. Spherical body. Okay. Passing through its center of the ms phi. Remember. The radius of gyration is a distance where the whole mass of a body is assumed to be concentrated. As correct. Next, mass moment of inertia of a uniform thin rod of mass m and length l about its midpoint and perpendicular to the its length is that is 85 is b 1 by third ml square. Thin uniform rod, okay, and it's how much? 1 by third ml square. You have to remember these answers. Mass moment of a thin rod. Here what is there? At midpoint, from its midpoint and perpendicular to its length, like this, from midpoint. Now here what is there? Mass moment of inertia of a thin rod about one end. Here going from one end, dash the mass moment of inertia of the same rod about its mid end. So this will be 86 is d, 4 times. So like this one, 4 times 4 by 3 ml square. So from this whenever it's going from its end, this is 4 by third, means 4 times of this whenever it's going from midpoint. The moment of inertia of a rectangular section having the breadth and depth center of gravity parallel to the width is parallel to BD cube by 12. So parallel to width. So 87 is B, BD cube by 12. Next, moment of inertia of a rectangular section having width and depth parallel to depth is asking, so dB cube by 12. So whichever they parallel they said, that will not be there for cube. The remaining side will be there for cube. This is depth, this is the breadth. They will tell parallel to base or breadth, then B into D cube. Which one they said? For that we should not keep cube. Okay. The moment of inertia of a square of a side A whose axis through its center of gravity is, so this square all the sides are A only. So any side you say A into A cube by 12. A into A cube means A to the power of 4 by 12. 90. Moment of inertia of a rectangular section, this width and this depth about x axis is. So you can just calculate 3 into, so about x axis is, x axis means this 3 centimeter. So 3 into 4 cube by 12. 3 1s are 3 4s are 4 1s are, this one square will go. So 4 square means 16. So 16. The moment of inertia of a square of side A about its base is A to the power of 4 by 3. So this answer you have to remember. About its base, square. Moment of inertia of a side square of a side A about its diagonal is. That is 92 is same as this one. About its base they said means this one you have to remember. About its diagonal means A to the power of 4 by 12, the normal one. For this moment of inertia what you have to calculate? First you think this whole body is there, then that moment of inertia, then subtract the which one is white portion is there, that one you have to subtract that moment of inertia. So BD cube by 12, that is the whole, minus small BD cube by 12. 93. Moment of inertia of a hollow rectangular section as shown in the figure about y axis is not same as about a x axis. Yes, it's a correct, because this is the hollow rectangular section. So what will be there? This x axis whatever is there, moment of inertia, that won't be in the y axis. That is because BD cube by 12 is not same as a DB cube by 12. Moment of inertia of a circular section about its diameter D is 5 d to the power of 4 by 64. Important. Moment of inertia of a circular section about its axis perpendicular to the section. About its diameter, this one. Perpendicular to its section is what? 5 d to the power of 4 by 32. So that is the polar moment of inertia actually, J. I of xx plus I of yy. I of xx plus I of y is this is one I of xx. So 2 into pi d to the power of 4 by 64. 2 1s are 2, 32s are. So this one will be answer. Moment of inertia of a hollow circular section as shown in the figure X is given by the, so pi by 64 into d to the power of 4 minus small d to the power of 4. The whole you think first is there. After that, the smaller one you have to subtract, whichever is. Moment of inertia of a hollow circular section as shown in the figure about an axis perpendicular to this section is same dash than the axis about x axis. So 98 is white. 2 times, because 64 is there, then pi by 32 is there about perpendicular. So this is how much times it is more? It is 2 times, because if you multiply with 2 this then 2 1s are 2, 32s are you get. So that's why it will be 2 times more than this answer. Okay. Moment of inertia of a triangular section of base B and height h about an axis passing through its center of gravity and parallel to base is 99 is d, bh cube by 36. Parallel to base for triangle, what is this? Bh cube by 36. Moment of inertia. Moment of inertia of triangular section of base B and h about axis, it's a base about an axis through its base and parallel to base. So this is parallel to base, through its base this one. Understand? This is through its base, this is parallel to base somewhere. Then bh cube by, correct, bh cube by 12. The moment of inertia of a triangular section, the moment of inertia of a triangular section of base B and height h about an axis through its vertex and through its vertex. So vertex means these are the vertexes, this corner point is called as a vertex. So from here it is passing through its vertex and parallel to base. Now this is parallel to base, S is dash then the passing through its center of gravity and parallel to base. It is how many times? 101 is A, 9 times. You have to remember the answer. These 2 questions are very important questions. According to parallel axis theorem, moment of inertia of a section about an axis parallel to the axis through the center of gravity IP is given by the IP is equal to Ig plus AH square. Moment of inertia of a thin disk of radius r about an axis through its center of gravity and perpendicular to plane of disk is 103 mr square by 2. For a disk you should remember mr square by 2. For cylinder also same, because cylinder is basically the thickest disk. You can cut the cylinder, that one will become the disk. Moment of inertia of a thin rod of a mass m and length about axis through its center of gravity and perpendicular to its length is how much? It is ml square by 12. Moment of inertia of a solid cylinder of mass m, radius r and length l about the longitudinal axis or polar axis is solid cylinder. So what I told you, solid cylinder means it is like a disk mr square by 2. Previously also disk means mr square. Disk means basically the little bit thicker circle. So if you add these thicker circles, what will become? 1 by 1, 1 by 1, 1 by 1. The cylinder will become cylindrical rod. Moment of inertia of a thin spherical shell of a mass m and radius r about its diameter is that is b 2 by 3rd mr square. Spherical here, spherical shell, you have to remember. Now moment of inertia of a sphere of a mass m and radius r about axis tangential to it. Okay, about its diameter 2 by 3rd. Tangent to it is how much? This 107 is d 7 by 5. Next 108. The moment of inertia of a, now here solid sphere of mass m and radius r is 2 by 5 mr square. Moment of inertia of a solid cone. Now solid cone, how much? Solid cone is about its vertical axis is this is 3 by 10 mr square. Force acting in opposite direction to the motion of the body is called force of friction. Yes, it's called force of friction. Whenever one body is moving this direction, then whatever the force acting on this body at the contact of surface, that is called as a friction force. Okay. Next question. Maximum frictional force which comes into play when the body just began to slide over the surface of other body is known as limiting friction. Friction experienced by the body when it is rest is known as a static friction, because it is in the rest. The ratio of static friction to dynamic friction is always static friction is greater than dynamic friction. So static by dynamic always greater than 1, because this one will be more. Static by dynamic they are asking. So static is 2, this is 1, means it is greater than 1. The friction experience of a body when in motion, that is known as a dynamic friction. Static friction bears a contact ratio to normal reaction between two surfaces independent of area of contact. Always friction is independent of area of contact between the two surfaces. It acts in the direction opposite to that in the body tend to move. That's correct. Friction property is what? Friction is not depend on area of contact. How much area it is contact, on that it won't depend, but it depend on surface. What is meaning of surface? It is rough, how much smooth. If it is smooth, then friction force will be less. If it is rough, then it will be. So its surface properties it will depend. Static friction is always dash the dynamic friction greater than the dynamic friction. The angle of inclined plane at which the body just began to slide down the plane is known as helix angle. So it is the wrong. It is called as the angle of repose. The angle which the normal reaction makes with the resultant reaction is called as angle of friction. Correct. So this is some inclined plane. Here is the body is there. This is some theta. This is some normal reaction, but there is some resultant reaction is there here. This is the some resultant reaction, or whatever this normal making with this alpha is called as the angle of friction, or pi. The angle of inclination of plane at which the body begins to move down the plane is known as the 119 angle of friction. The minimum force required to, so this at which angle it is going to fall down, that angle is called as the angle of friction. No, 119 A. The angle of inclination of a plane at which the body just began to move down the plane is known as the angle of repose. Actually, this one. The minimum force required to slide down the body of a rough inclined plane, body weight W on a rough inclined plane is. So this will be this forces. If you calculate, this is perpendicular force. This is W cos theta, and this one will be W sin theta. So this sin theta is in the parallel to this plane. So W sin theta will be our answer. 120. See. Now force required to slide down a body of a W on a rough horizontal plane is W tan theta is given. That is the wrong answer. W sin theta. A body will begin to move down an inclined plane of if the angle of inclination of the plane is dash the angle of the friction is it has to move down, then angle of inclination should be greater than angle of friction. Friction is going to hold, angle of inclination is going to fall. So falling should be more than the hold, then only it will come down. A body of weight W is required to move up on a rough horizontal plane, rough inclined plane. Now it's going to move up. with alpha, the effort required to pull the plane is given by the P is equal to W into sin alpha plus mu into cos alpha. So that is the C. So here why mu is came means it said rough. That's why mu came, friction coefficient. Coefficient of friction is the ratio of a limiting friction to normal reaction between the two forces. So F is equal to mu into N, friction force is equal to mu into N. So N is equal to mu is equal to F by N. So friction force by normal reaction. So that is the one. Coefficient of friction is the ratio of limiting friction to normal reaction. That's correct. Coefficient of friction depends on area of the contact only, nature of the surfaces only. So nature of the surfaces only. The force required to move a body up on a plane will be minimum if it makes an angle with the inclined plane is equal to, it's a minimum. Now we are not moving up and down. What is asking, what is the minimum force? If it is minimum means it should be first equal. Now we want to move up or down, then it should be greater or lesser. That depends. So it is equal. For minimum condition it is equal. A ladder is resting on a smooth ground and leaning against a rough vertical plane. The force of friction will act upward at its upper end. So this is the wall, this is a smooth end, this is the ladder. So here whenever it is slide down, what will be there? Here it is anyway smooth, so zero reaction is there, but here it is falling down, so reaction will be in the upward direction. The ladder is resting on a rough ground and leaning against a smooth vertical wall. The force of friction will act zero at its upper end. So here zero will be there. In a screw jaw, the effort required to lift the load is given by the, so always lift the load is plus will be there, lower will be minus will be there, because lower will be less, so that minus means you get less value. For lifting you need more force, for lowering you need less force. So in lifting you should be get plus, so then the more force will be W into tan of alpha plus pi. So 128 is B. 129. In screw jaw, the effort required to lower the load is dash the required to rise the load. So it should be less than. Just now we said. Efficiency of a screw jaw is given by the tan alpha by tan of alpha plus pi. Efficiency of a screw jaw is maximum when alpha is equal to 45 minus pi by 2. Correct. Maximum efficiency of a screw jaw is, these all are important questions, 1 minus sin pi by 1 plus sin pi. Velocity ratio in case of a inclined plane, inclined at an angle theta to the horizontal and weight being pulled up the inclined plane by a vertical effort is sin theta. What I told you, vertical effort, what will be the force? W sin theta. So sin theta. 133 here. An ideal machine whose efficiency is 100. So first of all, two types of machines will be there. One is self-locking and overhanging, I think so. Overhanging or non-self-locking. For self-locking, efficiency is less than 50%. For non-self-locking, it is greater than 50%. Just we'll see. Mechanical adjustment of a lifting machine is the ratio of the load lifted to effort applied. So 135 is B. Load lifted to, so W kg you lifted, but you applied only P. 2 kgs you applied, but you lifted 100 kgs. Then that is called as the mechanical advantage of a lifting machine. The efficiency of a lifting machine is the ratio of the, efficiency means output by input, that one we know, work done by the machine to work done by the on the machine. Mechanical advantage to velocity ratio, also called as the efficiency. So all of these. Okay, 137. If the efficiency of a lifting machine is kept constant, its velocity ratio is dash proportional to its mechanical advantage. Kept constant, so means efficiency is what? mechanical advantage by velocity ratio. Now this is some constant, suppose this is some 60. So 60 into velocity ratio is mechanical advantage. So basically mechanical advantage is directly proportional to velocity ratio. In an ideal mission, mechanical advantage is dash the velocity. Ideal mission means it is 100%. 100% means 1. So 1 is equal to mechanical advantage by vertical ratio, velocity ratio. So 1 into velocity ratio is velocity ratio, that is the mechanical advantage, it is equal. So in ideal mission it is equal. In actual mission, mechanical advantage is dash the velocity ratio. It's a dash the velocity ratio, it is less because efficiency is mostly won't get 100%, it is some 80%, 90% will be there like that. So why it is getting less? Because the numerator part is less, denominator is more. Suppose 1 by 2, 5 by 8 like this. In a lifting machine, if the lift a load of this much through a distance of this much by means of a effort this much and a distance of this much, the machine is ideal one. So just mechanical advantage is what? First of all, 1000 by 200 by velocity ratio is what? 1 by 0.2. Okay, 1 by 0.2. So this 0. Will go numerator. So what will become? 1000 into 0.2 by 200. This point, this 0 will cancel. So 200 by 200 will cancel, that is 1. So it is a ideal, yes, 1 means ideal, 100%. The machine having the efficiency less than 50% is known as it is non-reversible machine. Is known as non-reversible machine. If the efficiency is greater than 50% is known as a reversible machines. A machine which is capable of doing work in reverse direction means reversible machine. After the effort is removed, they are known as a non-reversible machines. That is the opposite they give. So 143 is B. No, it is called as a reversible machine. A machine is not capable of doing any work in the reverse direction after the effort is removed is known as reversible machine. No, it is known as a non-reversible machine. Both are wrong statements are given here. A non-reversible machine is also called as a self-locking, means this machine after moving here, if you stop, then it won't come in the back direction to do some work because of some stability. So that type of means it is locked here, means self-locking. At that position only it is stayed. So then that non-reversible, so it's stayed there means it is not coming return back, means non-reversing. So non-reversing is also called as self-locking. Now its position in that position only locking. Yes. Screw jaw used for lifting the loads is a non-reversible machine. So whenever you screw jaw when you use for tire replacement, so you move up to till this much height, the middle part portion, and you can release. It will be hold there only. You no need to hold to that position. It will by default it will won't come down because it is non-reversible machine. The weight of 100 Newton can be lifted by the effort of this much. The velocity ratio is this much. The machine is. So first of all 1000 by 80 and velocity ratio, this is how much? 0, 0. This is 12.5. So 12.5 mechanical advantage by velocity ratio 20. So basically how much you are getting? It is so 0.6 means around more than 60% is something you getting. So 60% means what? 60% means it is greater than 50%. Greater than 50% means it is a reversible machine. So it is a reversible machine. 147A. A self-locking machine. Self-locking means it is less than 50%. Less than 50%. The law of the machine is P is equal to mw plus C. P is equal to mw plus C. The mechanical advantage of a lifting machine is 1 by m. 1 by m. So this much we discussed in this video. The remaining questions will finish in the next video. So 2 parts, 1 subject will finish. Like that, all the subjects I will finish RS KURMI as well as RKJ. So what will advantage with you? You can increase the speed of watching. 2x 1x will be there in the YouTube settings. With that much speed you can see. So it will be revision for you. It will be very helpful for you for your exam point of view. Okay, so we'll meet in the next video. If you like my this video, please subscribe my channel and like the channel. And if you have any doubt, you can comment in the section. So whatever you need, I will provide. I will going to help you. Okay, thank you.